And so Brittany wants to look at some of these solving by resolving questions. And one of the most confusing things about them is this crazy east 60 degrees north way of explaining the directions. So we'll go over that. And so this is just two displacement vectors, or for the sake of argument, we'll say it's two displacement vectors. The first one, say it's the leg of a journey, is 560 meters east, 60 degrees north. Now, what east 60 degrees north actually means is that we are going to be starting from the east, which is by convention to the right, and then we're going to swing up 60 degrees to the north. Okay. So, this, in my opinion, is the easiest way to deal with vectors, which is to break them up into their component parts and then do the adding, because you don't have to do all the mental arithmetic or mental gymnastics that you normally do when you're doing sine and cosine law. Okay, so we started east, we swung up 60 degrees towards the north. That's what that means. So here's 60 degrees. We're going to break it into two components, one easterly component and one northerly component. And this is going to be 560 times cosine of 60 because it's the adjacent. This is going to be 560 times the sine of 60 because it's the opposite. And so 560 cosine 60 is 280 meters in the easterly direction. And I could probably do this in my head, but I don't want to. Times sine 60 equals 484. Okay, I'll carry 485. All right, we've resolved this 560 meters at east 60 degrees to the north into two components. And so we're going to call this displacement 1x, which is the easterly direction. And am I on the map here? Yes, I am. Okay, it's 280 meters east. And there we go. The room has shifted. And d1y is going to be 485 meters to the north. Okay. There's our first displacement vector. We've drawn it out east 60 degrees north. We've resolved it into its two components. Now let's get to the second displacement vector. And so we're starting in the west, and we're going up about 30. That's about 30, I'm guessing. I am guessing, by the way. Okay, so there we go. This is 30 degrees. This is 720 meters, the hypotenuse. And so this is the adjacent side, and so this is going to be 720 times cosine of 30. And this side's going to be 720 times the sine of 30, which is 360 meters. And that's going to be to the north. And 720 times cosine of 30 624 meters to the west. And so now I have the components of that second displacement. So this is delta d2x, and this is 624 meters to the west, which is opposite this direction to the east. And delta d2y is 360 meters to the north, which is the same as the original. Okay, now, instead of doing this thing, which we can do, which is to add those two vectors together, put them tip to tail. So this would be completely within the realm of possibility as well as doability. So we could approach the problem by trying to figure out what angle is where, and you can do it using parallel lines and perpendicular lines and complementary angles, and then you can use the sine and cosine law. But I much prefer this: break it into its components, add the components, and then reconstitute the final vector. What we do have to be aware of, though, is that this is east and this is west, and so when we go to add these components, it's not going to be just as simple as just adding those two numbers. We have to turn one negative, and so I'm going to turn this one, the east one, into negative 250 meters west, and I'm going to leave north as my positive. Okay, so delta dx altogether is going to be, this is maybe outside the realm of my computational ability, negative 424 minus negative 404 minus 60, which is negative 344. Yeah, I think so. Meters to the west. Okay. Delta dy, this is going to be 845 meters to the north. And so those are the two components of the final velocity. Now, what I have to do is I have to add these two components together. So there's 344, headed west, and here, totally not to scale, is 845 to the north. And so I don't think I have to take it beyond this, other than to say you're just using the Pythagorean theorem to find this last side, and then you're going to use some inverse trig function to find out what that angle is. So those are fairly straightforward. But that's how you tackle that kind of problem. Break each one into its components, pick a positive and negative direction, add those components together, reconstitute the vector over here.